Hello students, let us learn General Science for class 7 from the book Science Squad. Today we are going to learn chapter 5 Acids, Bases and Salts. In this chapter we are going to discuss about certain acids and its characteristics, about bases and its characteristics, and salts and its formation. Let us begin the chapter. We know that elements combine together in different proportions to form a large variety of compounds. For example, hydrogen reacts with oxygen to form water. There are more than 3 million compounds already known to us. Can we study these compounds separately? Is that possible? No. So, we are going to classify the compounds formed based on the properties. We can classify compounds as acids, bases and salts. Let us first discuss about acids. The name acid means sour in Latin language. Acids make up a class of compounds that taste sour. It reacts with certain indicators and produce positive hydrogen ions when dissolved in water. That is, acid when dissolved in water will produce positive hydrogen ions. The taste of acid is sour. The lemon and grapes contain citric acid. The unripe apples contain malic acid. Tamarind, that is known as imili, is sour due to tartaric acid. Vinegar is a solution of acetic acid in water. In cool drinks, carbon dioxide is dissolved to give carbonic acid, which gives a tingling taste. The souring of milk produces lactic acid. So naturally, we can see that there are a lot of acids present in varieties of fruits, drinks and other substances. The acids commonly used in the laboratories and industries are hydrochloric acid, HCl, nitric acid, HNO3, sulfuric acid, H2SO4 and acetic acid, CH3COOH. These are commonly used in chemical laboratories and industries. Sulfuric acid is called the king of chemicals. They should not be touched or tasted. That is, we cannot either touch or taste the acids. We know that they corrode skins, clothes, metals and most of the other substances. We know that acids contain hydrogen. Therefore, all acids produce positive hydrogen ions when they are dissolved in water. However, there are compounds which contain hydrogen but are not acids. Table sugar is an example. Let us now discuss about the properties of acids. All acids have a sour taste. All acid solutions in water turn blue litmus and methyl orange red. What are this blue litmus and methyl orange? These are our indicators. Acid react with more active metals to form salts and release hydrogen gas. That is, acid will react with the metals to form salt and hydrogen gas. You can see zinc is a metal. When reacted with acid like HCl will give you salt, zinc chloride with liberation of hydrogen gas. In case of zinc, you can replace with any other metals. Acid reacts with bases and basic oxides to form salts. Let us see. Metal, we read that it produces hydrogen gas, but when base reacts with the acid, it forms basic oxides and salts. Okay. For example, sodium hydroxide is a base. When it is reacted with acid like hydrochloric acid, it forms salt and water. Acid, when reacts with the metal, it forms salt and hydrogen gas. While base reacts with the acid to form salt and water. Basic oxide, that is NaO, that is sodium oxide, also reacts with hydrochloric acid to form salt and water. Let us now discuss about bases. Bases make up a class of compounds that taste bitter, react with certain indicators, and produce negative hydroxide ions when dissolved in water. So, we read that acids are sour in taste while bases are bitter in taste. Both will react with certain indicators. Acid produces positive hydrogen ions while bases produce negative hydroxide ions when dissolved in water. A base is a compound, every molecule of which is made up of one or more hydroxyl, that is OH group, attached to the atom of a metal. All bases are not soluble in water. Bases which are soluble in water, we'll call it as a alkalis. For example, sodium hydroxide NaOH, potassium hydroxide KOH are called alkalis. All alkalis are bases, but all bases are not alkalis because all bases are not soluble in water. Bases which are soluble in water, we'll call it as a alkalis. Quicklime tuna is a calcium oxide, while lime water is calcium hydroxide. Let us now discuss the properties of bases. Bases taste bitter. Bases are soapy or slippery in touch. Bases turn red litmus to blue and phenolphthalein to bright pink. So what is this red litmus and phenolphthalein? These are indicators. Bases react with acids and acidic oxides to form salt and water. Let us see, NaOH is a base. When reacted with sulfuric acid, it forms salt, sodium sulfate and water. When sodium hydroxide reacts with the carbon dioxide, it forms sodium carbonate, the salt and water. Acids are sulfuric acid, CO2 is an acidic oxide. When bases dissolve in water, they provide negative hydroxide ion, that is they produce negative hydroxide ion because all bases will have OH. Let us now discuss about the third compound, salt. Salts are neutral substances. When an acid and a base react, it forms salt and water. This reaction is called neutralization reaction. Sodium hydroxide, when reacted with acid, that is a base is a sodium hydroxide, reacted with the acid, nitric acid, will give you salt, sodium nitrate and water. This is an example of a neutralization reaction. In a neutralization reaction, the positive hydrogen ions from the acid combines with the negative hydroxide ions from the bases to produce water. The remaining part of the acid combines with the remaining part of the base to form a salt. You can see the equation. Na is separate, OH is separate, H is separate, NO3 is separate. So, OH of sodium hydroxide reacts with the H of HNO3 to form water. The remaining acid part is NO3 and the remaining base part is Na. When they combine, it forms NaNO3, sodium nitrate, a salt. Neutral solution. The solutions which do not change the color either to blue or red litmus will call it as a neutral solutions. These substances are neither acidic nor basic. Let us now discuss about the indicators. We can tell whether a solution is acidic or alkaline, that is basic, by using an indicator. Certain compounds are called indicators because they change colors depending on the solution to be tested as alkaline or acidic. For example, the common indicators are red and blue litmus paper, methyl orange, phenolphthalein, universal indicator and pH paper. These are all common indicators. So, let us take the litmus paper blue. So, when you dip the blue litmus paper in acidic solution, the blue color turns to red, whereas the red color litmus paper will remain red in the acidic solution. Let us now check out the blue litmus paper in the alkaline solution. It will be the same blue, whereas in acidic solution it becomes red. Now let us take the methyl orange. The color of the indicator is generally orange in color, but when a drop of methyl orange is mixed with the acid solution, it becomes red. So the orange to red will shows you the solution is in acidic. When orange changes to yellow, you can say it is a basic solution. Phenolphthalein generally it is colorless. Even in acidic solution it remains colorless, but changes to pink in color when it is dropped in a solution of basics. Now let us take the universal indicator, which is green in color. It becomes yellow in color in acidic solution and blue-violet in alkaline solution. These indicators help us to find out whether a solution is acidic or alkaline. Let us see about few natural indicators. Number one, first one is a litmus. It is the most commonly used natural indicator. It is extracted from lichens. It has a mouth that is purple colored in distilled water. As discussed earlier, when added to an acidic solution, the purple color turns to red. When added to a basic solution, it turns from purple color to blue. It is available in the form of solutions, strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper for our convenience. The next natural indicator is turmeric. So you must have seen when a shirt becomes yellow in color due to have some drop in curry, what will happen? The stain of the turmeric will be in your shirt. That turns the shirt into yellow in color. Now, when you apply the soap, which is being a base, is applied on the turmeric stain, the yellow color will changes to red. This shows it as an indicator showing you the change in the color. China rose. When China rose is applied to the acid solution, it becomes dark pink. When it is applied on the basic solutions, the China rose, which was applying a dark pink in color, it becomes into green in color. But there will be no change in the color for the neutral solutions. Let us have a chapter recap. Acids have sour taste, turns blue litmus red. Bases have bitter taste and turns red litmus blue. Bases produce negative hydroxide ions when dissolved in water. A base soluble in water is called an alkali. An acid reacts with the base to form salt and water. This reaction is called neutralization reaction. Certain compounds called indicators change the colors based on the solution to be tested as acidic or alkaline. This ends the chapter 5.
Vidya Prakashan Mandir Private Limited.